today we're going to talk about genetics, and I have Dr. Monsoor Mohammed here with me. And I want to start from the beginning, Dr. Monsoor. First of all, give a quick intro to who you are, and then I want to talk about genetics, what they are and how they impact our health.
Thank you, and thank you so much for having me. I've spent my entire career studying DNA and studying the genetics of the human being. Starting first with diseases, I specialized in the genetics of cancer, in the genetics of childhood development, autism, behavioral development, but more recently, really started to put an emphasis on understanding our genetic heritage, our inheritance, our genetic makeup, that operating manual.
What we're born into this world with.
This codification of how the human body works. And asking the question, really, why were we only studying genetics as it applies to disease? Why aren't we studying genetics as it applies to simply understanding how the human body works to ensure that we're doing this as optimally as possible, that we're living, we're eating, our environment, our lifestyle choices are as optimal per the individual as possible.
Well, I love that you said that, because when I've known Dr. Monsoor for a long time now, and when we first met, we'd never met in person. We had spoken, and when we sat down, I had my genetic testing done, which we're going to talk about. And he walked into the room, and he was like, "Oh, I already know you." He was like, "I already know exactly who you are just from your genetics," and it was so wild. So the fact that you're mentioning that, I mean, that is very important, because it really makes up who we are. You were talking about someone, that we could have an addictive personality. You can talk about that, we could be more prone to certain things just by our genetics. So explain that, because it's fascinating.
I think a pivot point for all of our viewers to understand is, at the core of it, your genetic makeup clarifies your operating manual.
Okay.
That's what your genome is.
Right.
So our genome is the entire operating manual. Okay, so let's start there.
Okay.
The miracle of the human operating manual, it's a 23 volume set. So think of a 23 volume encyclopedic set.
Okay.
Within those volumes, the paragraphs on the pages are your genes.
Okay.
Okay, so think of a 23 volume set.
Yep.
Made up of thousands of pages.
Okay.
On each page, there are multiple paragraphs. Each of those paragraphs is a gene.
Okay.
And each of those genes is an instruction telling your body, telling your cells how to accomplish the milieu of things that our body has to accomplish at any given point in time. Telling our cells how we're going to absorb the nutrients that we eat, how we're going to get rid of the toxins that invariably we're exposed to in the modern environment.
That's an incredible one. I can't wait to talk about that
how we are going to make the hormones that define so many aspects of our body through childhood to adolescent to adulthood to post, in case of women, premenopausal, perimenopausal, menopausal, which is going to be a theme for today.
Yes, I love it. And you had explained to me that our genes, because when people think about genetics, they're like, oh, my father had heart disease, so that means I'm going to have heart disease too, or this runs in my family. And I remember you had told me early on that just because something exists genetically in your family doesn't mean that that gene for you will express itself. So I think this is the conversation. It's an important one to have, because how our genes express, we're able to turn them on and turn them off, correct? Just by our lifestyle.
They do turn on and turn off by our lifestyle, our nutrition choices, our environmental exposures. The purposefulness with which we're able to do so is still a topic of discussion. So in other words, to say we've got 22,000 genes, which that's about how many paragraphs, 22,000 genes, i.e. 22,000 paragraphs, again, keeping it simple, for the analogy of the operating manual. To say that we can mentally think, I'm going to turn on gene paragraph 5, page 27, volume 3, we're not there as yet. But as a natural byproduct, absolutely, of our eating, our living, our lifestyle, our environment, genes do turn on and turn off. And we are getting a better sense of what are the things that might turn on and turn off some of the more important genes in the body.
I remember you telling me a story about kale juice. And as someone who is very active, obviously, in the health food community or in health nutrition community, healthy lifestyle, you were saying that it's not necessarily good for everybody, and it could turn off certain things. So can you share the story? I remember one of our first conversations, you shared this, and I thought this was so cool.
Knowing your background in nutrition and your love of all things healthy, it was just to make it, purposefully choose an example that was a bit of a,
oh my God, it was. Total.
And so what we were speaking of was cruciferous vegetables and the juicing of cruciferous vegetables, which, by the way, is an absolutely healthy and good option. But here was the example that we used. You see, there's this gene called the CYP1A2 gene. It's actually the gene that breaks down caffeine. So this is a gene, this is a paragraph, it's an instruction in our operating manual. And what does this instruction do? It tells our cells how to make an enzyme. And this enzyme, it's famous for what? It breaks down caffeine. So just by the way, the CYP1A2 gene, which you'll learn about later in the report that we're going to talk about, the test that we're going to talk about, the CYP1A2 gene makes an enzyme that breaks down caffeine. Okay, that's what it's famous for. But that same enzyme activates certain protoxins. So for example, if you're exposed to cigarette smoke, if you're exposed to a lot of these fumes and so on and so forth, and we used a specific example of a mechanic that's working, and there he or she is, he's going to work, she's going to work, and she's going to be exposed to all of these fumes and gaseous things as per his or her job. On the way to work, he or she decides to stop off and have a nice cruciferous vegetable juice. Here was the point. There are ingredients in cruciferous vegetables that turn on, per what you were talking about, turning on and turning off genes. Those ingredients in cruciferous vegetables can turn on the CYP1A2 gene, i.e. to make more of the enzyme. Okay, so what's wrong with that? See, that same enzyme turns some of the things that mechanic will be exposed to in his or her environment into more toxic byproducts.
Isn't that crazy?
So for a period of time, after drinking that wonderful green smoothie, cruciferous vegetable juice, your body, if you are then simultaneously or thereafter being exposed to certain particularly aerosolized compounds, things like polycyclic aromatic hydrocarbons, the type of things you get in cigarette smoke and so on and so forth, your body is actually being exposed for a period of time to even more toxic metabolites.
So, and the cool thing is, or the interesting thing is that we can actually get tested for that CYP1A2 gene, so that you know that if you are working in a certain environment, then you shouldn't be drinking your kale juice before you go there, right? So drink it after. Now, would it be better to drink it afterwards?
Certainly, knowing how long these toxins, for example, stay in the body, the half-life of these toxins. Number one, what is your level of exposure? Number two, number three, what version of the CYP1A2 gene you have, because this gene and these genes that we inherit, these paragraphs in our operating manual, that's the whole beauty of inheritance, that's what makes us different, come in different versions. So for example, the CYP1A2 gene comes in a fast version and a slow version. If you're the individual that inherited the quote-unquote fast version of the CYP1A2 gene, just by the way, you're the person that can drink coffee a bit later in the day.
That's me.
Right?
I can actually drink coffee and go to bed, drink caffeine and go to bed, no problem within like an hour. My daughter too. We tested my daughter as well, and her too. Fast metabolizer,
Fast metabolizer, okay? Myself, I'm the opposite. I have this slow version of the CYP1A2 gene. I need to cease and desist caffeine consumption by about 3 p.m. If I'm to be hopeful of getting to bed by about 10 p.m. Okay? So the first thing we want to know, and this is what we're going to talk about, in any system of the human body we want to study, what's that function? And this is a key, and it's worth mentioning now that as much as we're speaking about individual genes, nothing in the human body works based on just single genes. It's a system.
Right, everything is synergistic.
It's
synergistic. Everything works together, of course.
We're a complex bioorganism. Now, despite that complexity, we can study it. And we do start with individual genes, but it's important to understand how these genes work together in a symbiotic and an orchestral masterpiece, as opposed to individual playing instruments.
I love it.
So, coming back to it, you need to understand what version of the gene you have. You see, if you've got the faster version of the gene, if and when you are exposed to environmental agents that are metabolized by this gene, and when metabolized, those agents become, ironically, even more toxic inside of your body. You're going to do that faster. If we were both exposed to the same agent, you are going to be activating your toxin because you have the faster version. Here's the point. But if prior to exposure to those toxins, you already activated the gene, you already turned it on, which is, for example,
from drinking green juice or kale juice.
Or caffeine.
Or caffeine.
A cup of coffee.
Right.
See, anything that tells the body. And that's what your genes do. Many genes. So genes i.e. these instructions, some instructions in the human body, you want those instructions on all the time. Because those instructions are necessary for the basal things that have to be going on, sleeping, waking, waking, sleeping. Those instructions, those jobs have to take place all of the time.
Okay.
Other jobs, you want them to be done because, of course, the body wants to be as conservative as possible. So you want some jobs only to be done when necessary. And this is the concept of when genes are turned on and turned off. So the CYP1A2 gene, which makes this important enzyme, whose job it is to metabolize certain things, caffeine, certain toxins, actually ironically making them more toxic. And for the ladies out there, and men for that matter, the same gene, the same enzyme also metabolizes estrogen byproducts. So we need to understand this, and we need to understand
all
that
tied in together.
all tied in, absolutely.
So when you say, metabolizing estrogen byproducts, why is that important to us ladies who are in perimenopause or menopause?
So this is going to open the door now to, I think, the very theme of today.
Yeah.
I think we should start from the perspective of saying your estrogens, men and women both, let's just be clear, men, we don't have a monopoly over testosterone. Right? Ladies make testosterone as well, and ladies, you don't have a monopoly over estrogen. We make estrogens, and so in actuality, it's a cascade. In men and women both, there are 3 primary sex steroidal hormone classes. Progesterones, and by the way, the very name, progesterone, indicates that it is the progenitor. It is the precursor of what comes next.
Oh, okay.
And what comes next are the androgens, i.e. think testosterone.
Testosterone, I remember,
right? And then after that, estrogens. So here's the point. Menstruating ladies or menopausal ladies, you do not make estrogens until you first make testosterone. So your body converts progesterone into, let's keep it simple, testosterone or androgens as a class, and then you convert testosterone into estrogens. Okay? Now, in a healthy menstruating female, this cascade of progesterones to androgens, testosterone to estrogens, it's a cascade. It's happening in a circadian rhythm throughout the month. And this is the first most important thing, and one of the most missed messages when I speak to young women. I'm surprised even, and it's a sad reality that clinicians are not speaking to their female patients about this. So the first thing you need to know, if you're a healthy menstruating young woman, i.e. not in the pill or any hormone replacement.
Okay. And when you say, let's clarify younger meaning,
during their menstruating years.
So they're not in perimenopause?
Correct. Okay. As yet. And then we're going to get, because it's important to understand what happens prior to perimenopause. Yeah. And so while you are menstruating, the first most important thing is you need to understand in your monthly cycle, your estrogens are not consistent throughout the month.
No, because they go up, the progesterone goes up, the estrogen
they go up, they come back down. There's a nice little extra little peak just before flow begins. So here's the first important point. The human body, the female human body, was not designed in these incredible years from menarche to pre and perimenopause to be exposed day in, day out to the same levels of these hormones. And this is really, really important. Okay? We're designed, the body is designed to be exposed as a circadian rhythm, ebbs and flow. Right. Why is that so important? Because we often miss what's the importance of the importance of these hormones. These hormones, your progesterones, your androgens, testosterone, estrogens, what do? They turn on and turn off genes.
Okay.
Right? So when estrogens are at its peak, in the days of the female cycle that they peak, they literally, estrogens, bind to your cells, enter your cells, and turn on and off genes in a very specific manner. And your body was designed to have those genes turned on or off in the circadian rhythm of your monthly cycle.
So what happens, for example, I'm in menopause. So what happens to us ladies who are in perimenopause, let's talk peri, and then let's talk menopause, because as somebody who is in menopause, it is very interesting the changes in our bodies that have happened from, and just I've been in menopause for about a year now, just from like previously to now, and then now knowing what's coming down the the line. How can we help ourselves?
So you beautifully introduced it when you said A key here to this operating manual is that parts of the operating manual are expressed or turned on at specific times. And it's the expression of the operating manual, not just the version of the gene you inherit, but the expression of those genes that impact your body. So what you're experiencing going into menopause is you're now experiencing the radically and beautiful, one might say, changes that your cells are no longer expressing genes in the manner or in the identical manner that they were expressing when you were menstruating. Because when you were menstruating, genes were being expressed on and off in that circadian rhythm. They're still being expressed, many of them, but the rhythm, the way in which they're being expressed, and therefore the jobs that are being done in your body, because that's what genes do. When you turn genes on, they do things in the body. You are experiencing the awesome shift in your body from the expression of genes to now what is happening post-menopause or during menopause.
One of the things that comes up a lot, obviously, in menopause specifically is hormone replacement therapy and even bioidentical hormones. And this was fascinating that I learned from you, because when I went to go see Dr. Monsoor, I was experiencing just at the cusp of having some hot flashes. And at the time, I was on progesterone. I was taking bioidentical hormones from a doctor that I had went to see. And I remember you sat down with me and you gave me my report, and you're like, just so you know, I was in my late 40s, he's like, just so you know, if you're on any HRT or even bioidentical hormones, you must come off them now because of the way my hormones and my genes were expressing themselves. And I was like, wait, bioidentical, come off those? But I'm told that's what we're supposed to do when we get into menopause. And this was, opened up a world of like, oh my gosh, wow, because this is so important, ladies. And this is why I wanted Dr. Monsoor here, because understanding the way our genes and the way our hormones are expressed through our genes is critical to navigating perimenopause and menopause. So please explain that, because I think this is so important.
The importance of this needs us to classify the stages in hormone metabolism. And let's just make it clear that hormone replacement, BHRT, bioidentical hormone replacement, is an absolute godsend
for many women.
Many women. So it's not about whether it is blanket healthy or unhealthy per se. Not at all. It is about the uniqueness of the individual when you replace, quote unquote, those hormones, bioidentical or not. Okay? Because here's the thing. Independent of hormone replacement, in other words, the most bioidentical you can get are your own hormones. Right? And so a person's innate, a woman's own hormones, her own estrogens in this case, can be something that is her Achilles heel. Let's just make that clear. So in other words, your own internal hormones can be your Achilles heel depending on your genetic proclivity, your lifestyle, your environment, how your body reacts to those hormones can be wild. I mean, you take any 5 young women, any 5 women going through menopause, and each one of them will have their own stories as to what their body is going through or not going through for that matter. So to be clear, even when we're not speaking of hormone replacement, we are speaking of fundamental differences that can occur at the individual level. So of course, with that fundamental different person to person, or potential difference person to person, when you put back in hormones, bioidentical or not, you can't expect to have a uniform experience.
Everybody does. Everybody's so individual and different.
Very, very quickly, here's what we need to know. So, and per the comment that was made earlier that we could look at, and this is the beauty of reading an operating manual and knowing what comes about from that manual. You see, as we said, your hormones are a cascade. Progesterones to androgens. Now, of course, androgens give the body certain morphophysiologic, certain traits. Androgens, building muscle, leanness of muscle, metabolic rate, and so on and so forth. Estrogens, and these are simplifications, obviously. Estrogens, the covaciousness, the estrogenizing of the body, the feminizing of the body, and then, of course, the balance between the two. Now, because these are cascades, and the cascade is controlled by genes, and those genes come in different versions, faster, slower, optimal, less optimal, you begin to be able to paint this awesome picture by looking at the genes of a person. You begin to see this flow from progesterones to androgens to estrogens, where might any one given young woman, pre, peri, or postmenopausal, where might she be on the cascade? Is she the individual that is tending to produce more androgens per se, in which case she would be what we'd call androdominant? These are the young women, speaking plainly like yourself, that we discussed.
Oh yeah, my whole life though, I've had high levels of testosterone. It was a theme ever since, I was a young girl.
I didn't have to know anything else about you other than just looking at the genetic control of your cascade was incredibly skewed, in this case, speaking plainly, to your body making more androgens than estrogens. All things equal comparative to other Caucasian females of your age, BMI, and so on and so forth. Okay, so what we've got to understand here then, when we start to speak of BHRT and the pronouncement that was made for you, is after a woman's body, and this is going to be the most important thing you need to understand. So for the ladies out there going into menopause, you need to know, here we're speaking of everything in its innate state, before we've introduced any hormones, whether it be when you were on the pill earlier in life, whether it be BHRT or HRT in your menopausal, perimenopausal, postmenopausal period. What you've got to understand is this. The first thing you need to know is, what is your innate tendency, the balance between which you make your androgens and your estrogens? In other words, are you more androdominant? Are you more estrodominant? Are you sort of neutral in the middle, so to speak? Now, once your body makes estrogens, and let's clarify, menopausal or not, you're still making estrogens.
Do you?
It's much less, but you still make estrogens.
But I had a blood test done and it said that I have no estrogen or very low estrogen.
Because of course you're entering menopause starting off in the first place from having very low estrogens because you're androdominant.
Right.
But mono a mono, when a young woman goes from pre-menopause, perimenopause into menopause, her estrogen production does not shut down.
Okay.
But what does happen is this, and this is going to further explain your results. Your estrogens go from being produced in the ovaries
to the adrenals. Or the liver?
Actually, no, not the liver. Driven by and produced in the adipose, the fat tissue of the body. Well, how much fat tissue do you have? Not a lot. So your estrogens in a menopausal woman, the actual production site of those estrogens transfer from the ovaries to the adipose and fat tissues of the body. Okay. Now, the same cascade, the same genetic control is happening. It's just, number one, nowhere at the levels that it was before menopause. It is still there, and it will be still there, reflective of the original tendency of the body, the original how androgenized you are, how estrogenized you are, except everything is now muted. Okay. So when you need to understand this, you need to understand where you are, and just that simple understanding starts to give you an opportunity to appreciate body type. Why is one young woman, much easier for her to get those triceps and those lean muscles and calf muscles?
Like my business partner, Randy, she's able to really get cut arms, and she works out all the time. She's behind the camera, but it's true.
You can tell that quite easily.
Very thin,
And it's because Andy's genetic proclivity allows her to have a balance in her body that is skewed more towards androgens than estrogens. Now, a young woman who is producing more estrogens, again, because of that genetic cascade, which is innate, but which is colored. It can be affected by your nutrition, by your environment, by your lifestyle, body mass, and so on and so forth. Not to mention, of course, external hormones, which, by the way, we're getting a lot of estrogen mimics now in our environment.
Xenoestrogens from the plastics and
and so on and
the
so forth.
pesticides and all the other things that we're exposed to.
So, first part, know where you lie on the arc of, are you more androgenized, estrogenized, or in the middle?
And that will come down to our test, which we're going to talk about in a minute. And then once you know that, there are things you could do. So, for example,
better balance that. And starting with nutrition, lifestyle, environment, and even at that point in time, if you choose, under the guidance of a clinician, so important, under the guidance of someone who understands the intelligent use of hormone replacement. Now, you see, we're not giving hormone replacement for a one-size-fits-all. Ladies, you're not. Men, women, we're not one-size-fits-all. And would you think of something so radically important as how hormones affect the human body? And you think of the changes that hormones make, the good, the bad, and the ugly of them, to the human body, how could we hope to give the same hormonal regimen to
it's like diets, you know, like one person does really well on the keto diet, someone else does well on paleo, and someone else does really well on vegan, because we're all different. We're made up of different blood types. Like there's so many variables that go into who we are. Genetics are one variable, right?
One variable.
Right.
And this is why, you know, one of the things that really rubs me the wrong way is when we so overtly trivialize genetics and the jingoism of diets and the one size fits all. If there's one message that you can take from me today, we're not, you know, as many noses as there are in faces, there are the differences within our bodies.
Yeah.
And the differences within our bodies, as much as our cells, each one of us, our cells are doing the same, so long as we're breathing and we're relatively healthy, our cells are having to do the same jobs. But the efficiency with which any one person does the plethora of jobs, the thousands of things, comes down to genetics at a core, overlaid by nutrition, lifestyle, environment.
Yes.
And it has to be said, we're understanding more and more now that also symbiotic organism that lives within us, our microbiome. So
huge.
radically important as well.
Huge.
Okay?
Yeah.
So now let's complete per the question that you asked. Okay. Once you've determined where you lie, which our test does, genetically, innately, once you've determined where you lie on that scale of androgenization, estrogenization, or in the middle, the next and frankly the most important question for women, particularly women going into menopause, is this. Every molecule of estrogen in your body, whether you are producing it when you were menstruating, whether you are producing it now that you are menopausal, which is no longer being produced in the ovaries, but for example in the adipose tissues and the fat cells of the body, okay? Those estrogen molecules have to be metabolized. In other words, for a menstruating woman, the estrogens she produced in her menstrual cycle of December are no longer the estrogens in her body in her menstrual cycle of January.
Okay. And that's because of the blood flow?
It's because of when she made those estrogens in that circadian rhythm, they're made, they're exposed to the body so that they do what they do in the body, turning on genes, turning off genes, in a relatively small window, mind you. And then what does the body do? It breaks down, it metabolizes, it neutralizes those estrogens through the job of genes, i.e. the enzymes that those genes encode. And we each have different versions of those genes. So again, everything about how the female body responds to hormones is based on windows, it's based on discrete times. Now,
so in menopause, what about, is there a difference between women who are in perimenopause and menopause, or because
it's that shift that is happening?
So that's like that in between.
That in between, that the body is now shifting gears from where's the production site of the hormones, how much are being produced, how importantly is it being metabolized. So now let's quickly complete this point. So every estrogen molecule in your body, menopausal or not menopausal, has to be broken down. You're making it, you're breaking it down. Now menopausally, we're making it at a more consistent level, much more lower consistent level, but it's being made and it's still being broken down.
Okay. So it does still get broken down.
Absolutely, it has to get broken down. There's no cycle, but it's being made and metabolized, keeping it fairly consistent day to day to day. But importantly, and this is the key here, when you were menstruating, we said that your estrogens were largely made in the ovaries. And where are they largely metabolized? In the liver.
Right, okay.
Now your liver is an organ in the body designed.
Master detox organ in the body.
Indeed, and it's designed to take care of these metabolites and the breakdown processes.
So you're going to tell me right now, you're going to tell us, is that it's really important in menopause that your liver is healthy?
Absolutely.
That is really important. And you know what? It is so true, because I am just about to start a liver detox, because I could tell with my body if I, gain a little bit more weight than normal, or if I'm angrier than normal, right? And by the way, these are all signs and symptoms of being in menopause.
Absolutely.
So please, I didn't want to interrupt you, but I knew you were going to go there with the
all.
liver, because it is so crucial for us ladies in perimenopause and menopause that our liver is constantly
Your liver
being cleaned
is that
out.
awesome detox organ. When you think of if you were to design the human body, you wanted to design a part of the human body. You wanted to design a place that is the filtration, the HEPA filtration, the detox center.
It's like the
of
car
the human
filter,
body.
you think
Indeed,
about it, right? The engine filter.
However, there is a point here that needs to be made, and that's actually when you go into menopause, your estrogens are not broken down in your liver anymore.
So where do they get broken down?
In the very tissues that they're being made. Okay?
In the fat tissues?
In the fat tissues.
Okay.
Now,
so it's important.
for example, in the breast tissue of a woman, when does the epidemiologic increase of breast cancers occur?
Menopausal years.
Right at that menopausal shift. Wow. So here's the point. Let's tie this together. Very, very important. Let's tie this together. When you were menstruating, the estrogens that you produce are being metabolized in your liver largely, an organ that was designed to handle that filtration.
Okay.
When you go into your menopausal years, yes, your estrogen levels, again, ladies, this is if you're not on any type of hormone replacement, this is speaking of your innate capacity. Your estrogen, all of your hormone levels dramatically decrease, certainly your estrogens. They're now being produced in the adipose tissues of the body, such as the breast cells, and they're being metabolized there. Okay, now hold on.
Wow.
Every molecule of estrogen is metabolized into 3 different byproducts.
E2, E4, E16?
E16. So what is called 2-hydroxyestrogen, 4-hydroxyestrogen, 16-alpha hydroxyestrogen, as you've said, E2, E4, E16. Okay, so every molecule of estrogen has the option of going down one of these 3 different pathways. Every woman and man has all 3 pathways.
Okay.
Each of the 3 pathways are governed by genes.
I know.
Each of those genes
threw them out pretty quickly into the not so good
bucket.
I know,
right?
which is
So as much as every human being produces, every male or female, and let's focus on the woman, all 3 of the byproducts, 2 of those byproducts are much naughtier than 1. The 2-hydroxyestrogen, the 2-estrogen, 2-OHE, is considered the safer. It's actually considered a protective estrogen metabolite.
Yeah.
Okay, now remember, these are the metabolites of your estrogen, which is why we said the first
breaking
thing,
down.
breaking
So
down.
Before
right?
menopause,
So
it's breaking down in our
the
liver. In menopause, it's breaking down in the fat
tissues
tissue.
that it's
And
being
then
made.
once it breaks down, it's basically has 3 places it could go. Into
2,
E2, or E4, or
and
E16.
E16.
So in those simple terms.
Into those buckets.
E2 is better than the E4 and the E16.
By
E2 actually is
margin.
protective. And then there's the E4 and there's the E16.
That's right.
Okay, so once they have those 3 places, each of our genes tells them, or tells us how
our genes actually tells us which of the 3 buckets get filled up first or quicker in the first place.
And
then how quickly and slowly do you get. So the first is the filling of the 3 buckets, and which is genetically controlled, and lifestyle, and nutrition, and environment. And then after you've made these metabolites, you also have to empty these metabolites. So you still have to, so you take your estrogens, you break them down into these 3 buckets. Everyone is producing all 3, but not everyone is producing each of the 3 at the same rate.
Yeah, oh, right, exactly.
And then we've got to take those metabolites and get rid of them.
Okay.
When we looked at your genetics, what we found is you had a genetic proclivity. First and foremost, you were not estro-dominant. So you were not making a lot of estrogens to begin with, which was a good thing in your case. Why was it a good thing in your case? Because, of course, once you did make whatever estrogens you made,
my body needed
genetically, you were going down into that naughtier, that more inflammatory
That's right. So
estrogen.
It's good that I didn't have as much
of it in the first place. And of course, that was the alert. The alert was, your innate genetic makeup protected you in a way protected you by not making you overly estrodominant. Because if you were over estrodominant,
would have been a problem.
you would have been making a lot more of this naughty metabolite that is pro-inflammatory.
Okay.
Now let's talk science shop here just for one quick moment. What makes that 4-hydroxyestrogen so naughty?
This is the 4. That's the pro-inflammatory. Okay?
That's the pro-inflammatory.
Yeah.
So the 2 estrogen, safe, actually protective.
Yeah.
The 4, not so good. It's actually kind of naughty. We all produce all 3, but it's the levels of these things that we produce.
So what makes 4 so naughty? Is that
because once the body makes the 4, depending on the rate, the ability to get rid of the 4. So now we've got to flush that 4 away.
We want it out of
neutralize
our body.
it. We want that out of the body, which is genetically determined.
Okay.
So depending on the ability of us to flush out the 4, if we are not flushing that 4 estrogen quickly out of the body, 4 estrogens, 4-hydroxyestrogens, literally breaks down in the cells into these extremely toxic, extremely inflammatory molecules known as quinones. And these things cause DNA changes. They change the genetic material of the cell, leading to the potential of what we'd call mutations, leading to the potential of those cells,
issues and
leading to other things that we prefer not to speak of, i.e. the big C, cancers. Now let's put it all together now. When you were menstruating, where was all of this happening? In the liver.
The liver.
Liver is designed
That's its
more
job.
so. That's its job. But when you go into those menopausal years, if
adipose tissue is not designed. That's not their job.
It's not their primary job. And so if you did not know that your genetic proclivity, your genetic predisposition was to make more of that naughty 4-hydroxyestrogen, and you did not know if you were very efficient at getting rid of that 4-hydroxyestrogen, and if you were not, and those 4-hydroxyestrogens make those toxins, literally bona fide toxins, being made internal inside of your cells, then if your detox genes were suboptimal.
Favorite part, the detox genes.
Because then you've got to rely on your detox genes.
So because you're adipose, so women, and this, by the way, I can't even wait to tell you about the tests that you can get so you know what your genetic makeup is. So in menopause, those detox genes are crucial at helping us get rid of those bad estrogens.
Absolutely. Getting rid of the bad estrogen byproducts.
Got it.
As well as all of the
Clearing
other things.
out the 4 and the 16 out. Okay.
Right. And the 4 particularly.
The 4 particular. Okay.
Mind you, all of the other things, your heavy metals, your environmental toxins, your leftover pesticides on the vegetables that you might be eating, all of those detox processes, by the way, they don't just happen. They're things that your cells do by virtue of the instructions of important genes. So now look at it. We've got to know, when we speak of the individuality of the person, and when we speak of putting 10 different young women on the same hormonal protocol, right? Same protocol. Yet in the background, we did not know whether that young woman was estrodominant, androdominant. We don't know whether she is more predisposed to making E2, E4, A16. We don't know if she is.
This is why genetics are so important to know. And it's so it should be part of every part of we know what we try, I guess, trial and error for the diets that we're eating, but it should be part of everything we do. Everybody should have a hormone test to know what their genetics are.
When intelligently done.
Yeah.
And you
that's a good point.
You introduced it, and so for the audience out there, again, do not think that these results define you without any hope for change or optimization. They most certainly define your predisposition. And understanding the uniqueness of that predisposition is key.
Yeah.
Why? So that you're fatalistic about it? Not at all.
No,
not at all.
It's fabulous because you can
then you actually do
take control
something
and you can do something exactly.
Absolutely. But the least of it is, once you know your individuality, at least you can now better inform yourself and your clinician, obviously informing you, working together, always working together with a healthcare provider, a clinician that is dedicated to your individual health. Once that clinician understands the difference between you and Randy or Bonnie or Paula, what where are you on the spectrum? What are your proclivities? What would be a safe replacement cocktail, a BHRT cocktail, if there is such as one for you? But what would it be uniquely for you? And by the way, do we have to help the body do a better job of making more of the 2-hydroxyestrogen, which incidentally we can do, or at least we can influence the body to make more of the protective
or detox
it better. And that's a key, because at the end of the day, and I know this is your love and your passion, it's what you specialize in, because at the end of the day, we are speaking of cellular processes. You know, we think of toxins as the stuff we can touch, you know, the environmental things, and that's a very important source of toxins. But how many of us, we forget that internal processes, such as what we've just discussed, such as estrogen metabolism, is making, or these processes are making internal toxins that we must equip the body to get rid of. And you know, so many times, you know, sometimes, and I see this, and I'm going to speak plainly, for some of the clinicians that might be out there, when we talk about, you know, detox and detox protocols, these are not things to be taken lightly as though they're sort of airy-fairy considerations. There are important considerations to improving the capacity of the human body to get rid, to improve the detox potential of the human body. There are absolutely things we can do, things that we can do to improve liver function, things that we can do, micronutrients, lifestyle choices, avoiding certain environmental things that improve the overall detox capacity of the person.
Thanks for watching. Be sure to check out part 2 of my interview with Dr. Monsoor Mohammed, where we talk about detox genes and the important role that they play.